हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार और आइए स्टार्ट करते हैं क्वेश्चन रिलेटेड टू buoyancy एंड फ्लोटेशन। फ्रेंड्स, मैंने इसका थ्योरेटिकल पार्ट ऑलरेडी डिस्कस किया है, जिसका लिंक मैंने अपने डिस्क्रिप्शन बॉक्स में दिया हूं। आप वहां से उसे चेक कर सकते हैं। कोई भी डाउट हो फ्रेंड्स तो आप मुझे कमेंट बॉक्स में पूछ सकते हैं, मैं उसका आंसर देने की पूरी कोशिश करूंगा। तो फ्रेंड्स आइए स्टार्ट करते हैं क्वेश्चन। फ्रेंड्स, दिस क्वेश्चन इज रिलेटेड टू सम डेरिवेशन। Here, question is related to cone, solid cone, and we have to derive that this value we have to derive. Now understand the question. A cone of specific gravity S is flowing in water with its apex downward. It has a diameter d and vertical height h. Shows that for the stable equilibrium of the cone, h should be less than 1 by 2 in bracket d is square, capital D is square, s to the power 1 by 3 upon 1 minus, this is 1 minus s to the power 1 by 3 bracket close to the power 1 by 2. Like this we have to derive. Now first understand here friends, we are talking about a cone which is floating in water. Okay, its apex is downward and it has a base diameter of capital D and vertical height of h. So here data has given specific gravity. S is the specific gravity of cone, and we know that friends, specific gravity S equal to density of body upon density of standard fluids, or we can say water is the standard fluid, so S is equal to density of body upon density of water. Okay friends, now here here it is saying that, friend, this is the cone. This is the cone we are going to talk about. Its base is equal to capital D, which has given, and the height which has given capital H. Now friends, you see here it is floating condition, so somewhere here I assume that, or we can say we assume that at this level liquid surface is there, or we can say water is there. This is the water, so water surface is up to this level. So what is the dia of this point? This dia is equal to a small d. Okay, and the depth, or we can say height, from the apex height is there, which is small h. Okay friends, so at base radius is equal to capital R, and this point radius is equal to small r. Now you see here friends, these 2 points, G is the center of gravity of the whole body. G is the center of gravity of the whole body, and B is the center of buoyancy, which is at the center of volume of liquid displaced. So this much volume of liquid is going to displace. तो इसका सेंटर क्या होगा? इसका सेंटर होगा center of buoyancy. Okay friends, now we know that, and one more point is that here friends, the apex angle which is making here by two sides is 2 theta. So one side is equal to half, so we can say this is the theta. Now one more point is there here friends, what is the height of the center of gravity from the apex? What is the height of center of gravity from the apex? So center of gravity AG, A to G is equal to, in the case of cone, 3 by 4 into total distance. So for center of gravity of the body, AG 3 by 4 into capital H. Similarly, for center of gravity of this cone, or we can say center of buoyancy of this cone, AB is equal to 3 by 4 into small h. Okay friends, things is getting clear. Now if you consider this half part or this part, so friends, here you see this is point A, and this is the surface level. So this is the surface level, and this is the base level, this is the base level, and it is making half angle theta. So this is half angle theta. Now friends, here you see this surface level is at a small distance h, and this base is at capital distance, or you can say capital H. Now here friends, you see here in this triangle, up in this triangle ACZ tan theta is equal to what? Capital R upon capital H. Similarly here in APQ tan theta is equal to small r upon small h. So here from here you can say that friends, this capital R upon capital H, a ratio will come. Ratio we can write here, tan theta is equal to capital R upon capital H is equal to small upon small h. We can use this relation in the derivation. Okay. Now friends, here it is saying that we have to find, so that for stable equilibrium. So first we will consider, for floating body we will find the metacentric height. For easiest to understand, let me explain first what we have to determine to derive the equation. Friends, you see here, for a floating body, 3 points is there: center of buoyancy, center of gravity, and metacenter. If metacenter is above the center of gravity, then body is in stable equilibrium. It means one more point is there here, friends. Here, what is the metacentric height? I told you that m should be greater than g for stable equilibrium. And this gm, what is gm? Gm is the metacentric height. Gm is the metacentric height. So for stable equilibrium, gm should be greater than 0. Okay, first we understand the concept. For a stable equilibrium, or we can say here missing is there, stable. For stable equilibrium, gm should be greater than 0. Okay, now what is the metacentric height? Gm? Gm equal to I least upon volume of liquid displaced minus Bg. Okay, Gm equal to I least upon volume of liquid displaced minus Bg, or I list upon volume of liquid displaced is equal to what? This Bm. Or we can say that here, friends, this Bm value is equal to what? I list upon volume of liquid displaced, which is written here. Okay, Bm is equal to this value, and Bg is equal to what? Bg is equal to, here you see, here I already explained here, friends. This Ag value is equal to how much? 3 by 4 into h, and Ab value is equal to how much? 3 by 4 into small h. So this distance is equal to what? This distance Ag minus Bg, it will give the Ag minus Ab. Ag minus Ag will give the distance of Bg. So from here, this Bg value is equal to what? 3 by 4 capital S minus 3 by 4 into small h. So it will give 3 by 4 capital H minus small h. Why I am finding, friends? Why we have to find this Bm and Bg? Because this metacentric height Gm is equal to this value Vm, or I list upon volume of liquid displaced minus Bg. So Bg value from here we are able to find 3 by 4 capital H minus small h. Okay, now we have to determine these values, I list upon volume of liquid displaced, so that we can put this value, because for stable equilibrium I list upon volume of liquid displaced minus Bg it should be greater than 0. So जो भी वैल्यूज आएगा उसको इस इक्वेशन में पुट कर देंगे, तो हमारा जो डेरिवेशन है वह कंप्लीट हो जाएगा. Okay, friends, so we have to find these values. Why am I explaining this one? Because concept should be clear. क्योंकि हमें बस यही फाइंड करना है, इसी को अंडरस्टैंड करना है. GM वैल्यू कितना होता है? दिस वैल्यू होता है, और इट शुड बी फॉर स्टेबल इक्विलिब्रियम इट शुड बी ग्रेटर देन 0. सो हम इस इक्वेशन को यहाँ पुट कर देंगे और सभी वैल्यूज को फाइंड करके इस इक्वेशन में डाल देंगे, तो हमारा डेरिवेशन कंप्लीट हो जाएगा. फिर उसको हम रीअरेंज कर लेंगे. नाउ फ्रेंड्स, गेटिंग, आइए फ्रेंड्स अब इसको सॉल्व करते हैं. नाउ वी नो दैट for stable for floating body, we know that friends, weight of body equal to weight of fluid displaced. Okay, weight of body equal to weight of fluid displaced. So weight of body कितना होता है friends? Weight of body is equal to density of body into g into volume of body equal to weight of fluid displaced कितना होगा? Density of fluid into g into volume of fluid displaced. Okay, so from here g to g will cancel out, and if you divide by here rho f, so rho b by density of body upon density of fluid into Vv, volume of body equal to volume of fluid displaced. We know that friends, I already explained here, the density of body upon density of water, we can say this is the specific gravity of the body. So from here friends, this value is equal to S. So here this Vv equal to VFD. We'll put it here friends. What is the volume of VV? Body of volume of body. For in the case of cone, volume of body is equal to 1 by 3 into pi r square into capital H. So one for body 1 by 3 into pi into capital R square into capital H, and volume of liquid displaced कितना हो जाएगा? This is the body. So इसका वॉल्यूम कितना हो जाएगा? 1 by 3 into pi into capital R square into capital H. Similarly here, this is the body, this is the volume inside the water. तो इसका कितना हो जाएगा friends? 1 by 3 into pi into small r square into small h. We will put it these values here. So S into 1 by 3 pi into capital R square into capital H equal to 1 by 3 into pi into small r square into small h. So from here 1 by 3 and 1 by 3 cancel out, pi to pi cancel out. What is left here? S is the specific gravity of body into capital R square capital H equal to small r square into small h. Okay. Now here friends, now here I explained to you what is, we will find the value of capital R and small r. Okay, and we will put it here in this equations. Friends, I already explained here. You see in this triangle, tan theta is equal to capital R upon capital H and tan theta is equal to small r upon small h. So from here r equal to what is the value? Capital H into tan theta, and here is here capital R is equal to capital H into tan theta, and here small r equal to small h into tan theta. We will put it here. So from here friends, from here see this r equal to s tan theta, capital R is equal to capital H tan theta, and small r is equal to small s tan theta. We will put it this value in this equation. So what we will get here? R square is there. Here R square is there. So S into capital S tan theta whole square into H okay, into H equal to what is left here? R square. So R value is equal to S tan theta. So S tan theta whole square into small h. Friends, here you see S is S. Okay, this H square into H cube into tan square theta equal to here H square, small h square into small h. So H small h cube into tan square theta. So from here tan square theta and tan square will cancel out. What is left here? S into S to the capital S to the power 3 equal to small s to the power 3. So from here we will get the value small h is equal to capital H into s to the power 1 by 3. So one relation we are getting here friends. One relation we are getting here. Okay. So h small h is equal to capital H into s to the power 1 by 3. why we are deriving this one? What is the value of means? What is the meaning of this one? Where we are using this one, this equation, friends? I told you that here this bg value is equal to what? 3 by 4 capital H minus small h. So we will put it here small value in this equation. So from here we are getting the value of bg. Okay, we'll put it later. Or here bg value we are find here, bg value is equal to 3 by 4 capital H minus small h. So 3 by 4 capital H minus small h value will put it here, h into h to the power 1 by 3, or here friends bg is equal to 3 by 4 capital H 1 minus h to the power 1 by 3. Okay, so bg value we are finding here. Okay, now this part is over. Bg value in terms of h and s we find. Now we have to find this I and I list and volume of liquid displaced. Okay, now friends, here you see this Bm is equal to I list upon volume of liquid displaced. We will find here, friends, I list is the moment of inertia at this liquid surface level. Moment of inertia at this liquid surface level. We will not take at this point. We are taking here only on the liquid surface. Whatever section is there, we will take the least moment of inertia. If it is rectangle, means two moment of inertia will come, maximum and minimum. So we'll take minimum only. Here it is a circle, so either anyhow x or y both are same, so we will take moment of inertia of the circle. So I list is equal to what? Pi by 64 into d to the power 4. Okay, and volume of liquid displaced is equal to what, friends? We will take volume of liquid displaced this much only. This is the volume which is inside the water, so this much volume is the liquid displaced. Okay, so what is the volume here? What is the volume of cone? Volume of liquid displaced VFD equal to 1 by 3 into pi into small r square into small h. We'll put it here. Okay, we will convert this one d into 2r. We will convert in the radius form. So pi by 64 into 2r to the power 4 upon this volume of fluid displaced, volume of fluid displaced 1 by 3 pi into small r square into small h. So after simplification, friends, what is left here? If you simplified, here, you see pi by 64 into 2 to the power 4 is equal to 16 into r to the power 4, and here 1 by 3 pi r square into capital H. So r square into r to the power 4. What is left here? R square. 16 to 64. So 16 into 4 into 64. So 4 is there. Pi to pi cancel out. Okay. So what is left here? R square divided by 4 divided by h divided by 3. So from here this 3 will go up and 4 will come down. So 3r square by 4h. So from here we are able to find this I list upon volume of liquid displaced. So this value is equal to 3r square by 4h. Okay friends, so Bm is equal to this value we are find 3 into small r square upon 4 into small h. Okay, this value will put it in this equation. So this term value we are able to find, this term value we are able to find. Now we'll put it here and solve it. Okay friends, now put it here and we are going to solve in this equation. So here you see I list value is equal to, in this equation, this value how much is there? 3r square by 4h, and Bm value is equal to, already we calculated here, sorry, Bg value is equal to 3 by 4 capital H 1 minus h to the power 1 by 3 So we'll put it here, and what we are getting here, friends, if you put it here, 3 into small r square upon 4 into h minus 3 by 4 capital H 1 minus h to the power 1 by 3, it should be greater than 0. So this is the condition. This is the condition. Now friends, now friends, you see here, what we will do here, 3 by 4 r square, small r square upon small h minus 3 by 4 capital H bracket 1 minus h to the power 1 by 3 bracket close, it should be greater than 0. So this term, this whole term, I am sending this side. So what is left here, 3 by 4 small r square upon small s should be greater than, because here greater than sign is there, should be greater than 3 by 4 capital H 1 minus s to the power 1 by 3. Okay friends, so this 3 by 4 and 3 by 4 is cancel out. So what is left here, small r square upon small s should be greater than capital H 1 minus is 1 minus h to the power 1 by 3. Okay, now friends, now I already explained you one more point here, tan theta is equal to capital R upon capital H equal to small r upon small h. We will use this equation because here what we have to find, friends, first what we have to derive, this h should be less than 1 by 2 d capital D square h to the power 1 by 3 upon 1 minus h to the power 1 by 3 to the power 1 by 2. So the term should be come in the capital D. This three term is there now, s term, d term and s term. We have to determine in this term only. So friends, we are able to derive up to this. So r square upon small r square upon small h should be greater than capital H 1 minus h to the power 1 by 3. Then what we will do next? This r square value we have to find in the terms of capital D. Okay, then we will put it here. How we will put it here, friends? How we will put it here? You see, the tan theta is equal to capital R upon capital H equal to small r upon small h. So what we will do here? This term should be equal. So we will multiply with 2 both sides, 2r upon capital H into 2 into small r upon small h. So here what relation will come? Capital D upon capital H equal to small d upon small h. Okay. Now here, from here we will find the value of d, small d, equal to capital D upon capital H into small h. Why we are finding here, friends? Because first what we will do, we will convert this small r in terms of d, term, small d. So how we are able to convert this? Small d is equal to 2r, so r is equal to d by 2. Okay, so we'll put it here. What it will come? D square by 4 into small h. Small d square by 4 into small h should be greater than h 1 minus h to the power 1 by 3. And then we'll put it here, this d value from here. So capital D into small h divided by capital H whole square divided by 4 into h should be greater than capital H and this term. Getting, friends? If you open this one, then what is left? What is coming here? Capital D square into small h square divided by capital H square upon 4h. Like this it will come. Capital D square into small h square upon capital H square into 4 into small h should be greater than this h and this term. Okay. So from here, small h to this h square, one term cancel out. So what is left here? D square into small h upon 4 into capital H whole square should be greater than this term. Now we know that, friends, Already we find here one relation into small n into capital H. What is that relation, friends? What is that relation we are able to find? Okay, here is there. Small h is equal to capital S to the capital H into S to the power 1 by 3. So we will put it here in terms of capital H. We'll put it here. H value, small h value is equal to h into S to the power 1 by 3. Okay, so we'll put it here. H, capital H into S to the power 1 by 3. Okay, all terms is same here, d square. Okay, 4 into capital H whole square. This term is the value of small h, so we'll put it here. It should be greater than capital H bracket 1 minus s to the power 1 by 3. Okay, so from here h to h cancel out. Okay, so and this term will send this side and this term will send this side. So what is left here, friends? D square. Okay, s to the power 1 by 3. Okay, this 4 is okay, this term will send this side, so 1 minus s to the power 1 by 3 should be greater than, this term will go this side, so h square, or we can say h square should be less than d square s to the power 1 by 3 upon 4 into 1 minus s to the power 1 by 3. Or friends, if you say this 2 will send this side, what it will come? H should be less than d square s to the power 1 by 3 upon 4 into 1 minus s to the power 1 by 3 bracket close to the power 1 by 2. Or it will come, friends, here h should be less than, जब हम 4 to the power 1 by 2 is equal to what? 2. So friends, जब हम 4 को इस ब्रैकेट से बाहर निकालेंगे तो क्या आ जाएगा? 1 by 2 bracket d square s to the power 1 by 3 upon 1 minus s to the power 1 by 3 bracket close to the power 1 by 2. Okay, so from here we are able to derive this one. Capital H should be capital H is less than 1 by 2 and these terms. Okay, friends, but what is the concept here? Main concept is that, friends, I want to repeat once again so confusion is should not be there. Main concept is that here we have to find these terms. Metacentric height is equal to gm. Okay, and we know that gm equal to this bm minus bg. Okay, and this bm is equal to I list upon v volume of liquid displaced minus b into g. Okay, we have to find only these values, and it should be greater than, for stable equilibrium it should be greater than 0. Then what we can find here? We know that weight of body is equal to weight of fluid displaced. One relation will come from there and one relation will be from here, and one relation will find the capital H into small h. Okay, so these 2-3 relation will find and put it there in that equation, in this equation, and we will simplify it, then derivation will be solved. Okay, friends. सो फ्रेंड्स, मेरा एक्सप्लेनेशन अच्छा लगे प्लीज लाइक कीजिए, कमेंट कीजिए. कोई भी डाउट हो किसी पॉइंट पर, अगर आपको समझ में ना आ रहा हो तो आप मुझे कमेंट बॉक्स में पूछ सकते हैं. मैं उसको आंसर देने की पूरी कोशिश करूंगा, फ्रेंड्स. सो थैंक यू.